Hello, today we're going to be presenting our project called Maharlika Health App. We are Group 2 LBYCPEI IEQ for students. All of us are taking BS Computer Engineering. So Nathaniel Moises Antonio, he did some of the controller and most of the models. He also did some of the FXMLs. John Carlo Chengroa did some of the services, most of the controllers, and almost all of the FXML and CSS. And then Vince Randolph Returan, he did most of the calculations as well as some of the data management. And Wayne Talentino did most of the encryption as well as some of the data management.
Many Filipinos struggle with lifestyle diseases such as obesity and diabetes due to overwhelming health information and payable resources. While UN Sustainable Development Goal 3 aims to improve global health access, existing fitness apps such as Fitbit and MyFitnessPal are still behind a paywall and not very accessible for Filipino users. They lack local relevance, offering unfamiliar meal recommendations, excluding Filipino foods. This gap is especially critical in smaller towns where culturally tailored affordable health tools are not very readily available and are behind a paywall. We created a free Filipino-made health app using Java that tackles local health challenges. It provides secure login with password reset, personalized meal plans, and exercise routines based on your BMI, easy calorie tracking and profile management, professional dashboards with error handling. Unlike foreign apps, it's designed specifically for Filipinos, offering culturally relevant tools to replace unreliable online health searches and make healthy living accessible everywhere, especially in smaller communities.
So this is the walkthrough of our app. So here is the login page. You can enter your username as well as your password. Here's the forgot password page, the reset password. You can enter your username, the reset key that's going to show on your profile, as well as your brand new password, and it's going to confirm it as well. So here's the account creation page. This is where you can input your personal details, like so, and you can hit create account, but obviously I've already created mine, so I can click close. And I've entered my account details. If I press like enter, it's not going to recognize, as well as if I put another in my username, it's not gonna recognize as well. It has to be the same. Here is the dashboard. So this is what you've already inputted in the account creation page as well as the time goal. The current BMI is calculated initially, but you can select BMI calculator, so you can actually enter your age as well as your gender. So it is going to be more specific. Like so, if I click calculate, here's my BMI. I can set it as my current BMI, so it's going to update both height, weight, age, and gender into my actual account. Like so. As you can see here, this is the user profile. So you can change everything. Here's the reset key, so you can copy this just in case you forgot your password as well as your current health metrics, as well as your goals. You can go back to dashboard, and let's talk about the three main features of this program. To select exercise, basically you can select a specific kind of exercise like endurance, then let's say no equipment for now, as well as let's say no injury. It's going to show nothing because it's way too specific. But if I, for an example, remove this and replace it with weight loss, it's going to show squats. There we go. Then I can go back to dashboard, and it's going to immediately update it for you. In the select diet, it's pretty much the same thing. You can select your dietary preference, like a vegetarian, then I guess you have diabetes, or let's say you also have allergies, then these are the recommended food options for you. So it updates. So I guess let's select oats, basically tofu as well. And if I click save on this, it's going to update that your current diet is also vegetarian. Then you can also select your meal plan. So here's your meal planner. So in breakfast, you can select breakfast items like, let's say I want to eat oatmeal for breakfast, then salmon as well as quinoa for lunch. Let's select salmon. And for dinner, I guess I want to just eat Greek yogurt. So it's gonna update the calories consumed, calories burned, as well as the net calories. For calories burned, you still don't have any, but yeah. So you get your net calories. So if you can save your meal plan, it's gonna save it successfully. So if you close this, it's actually gonna update here in the net calories. So the last two features of the program is to log out, and then the final feature is to exit the app.
Abstraction simplifies complex systems by exposing only essential features while hiding implementation details. In our health application, this is demonstrated through high-level methods like calculate. While it appears as a straightforward method to users, it internally handles intricate processes, fetching calorie data from diverse sources and executing algorithms to compute notebooks. This shields users from underlying complexities such as database queries or nutritional calculations, allowing them to interact with a clean, intuitive interface. Encapsulation safeguards data integrity by bundling related data and methods within a class while restricting direct access. Our user class exemplifies this. Critical attributes such as username, password, and height are declared private. External code can't modify these fields directly. Instead, controlled access is provided via public methods like getters and setters. This ensures validation rules, like password strength checks, are enforced centrally, preventing invalid states by exposing only what is necessary, hiding how data is managed. Encapsulation maintains security and consistency across the application. Inheritance promotes code reuse by allowing new classes to build upon existing ones. Our application leverages this in two key ways. The main logic: the health profile class delegates BMI calculations to a dedicated BMI class, inheriting and specializing its health metrics functionality. To Java ecosystem, we utilize Java's built-in inheritance hierarchy. For instance, all classes implicitly inherit from Java's object class, enabling us to override core methods such as toString for custom behavior. Similarly, JavaFX components inherit methods like setVisible from the node class, ensuring consistent behavior while minimizing redundant code. This hierarchical design streamlines development and enhances maintainability. Polymorphism enables flexible interactions with objects through a unified interface. Our app implements this via method overriding, customizing inherited behaviors like overriding toString to return tailored user health summaries instead of generic object references. 2. JavaFX components. Polymorphic methods such as setTitle, setContext, and showWeight work across diverse UI elements, such as alerts and buttons. Despite each element having unique implementation, they share a common interface from a parent class. For example, alert.showAndWeight dynamically adapts to the alert's specific type of information at runtime. This flexibility allows us to write concise, adaptable code that scales with features and additions.
Here we have the UML class diagram, which outlines the key components of our system and how they interact. Each class represents a distinct entity with its own attributes and behaviors. Notice how the relationships, like the inheritance, help us visualize the dependency and hierarchies of each of the classes. This diagram was very instrumental in guiding our implementation and ensuring modularity within our project. Moving on towards the MVC, our system follows an extended model view controller architecture that includes a dedicated service. This addition helps isolate the logic from both the controller and model layers to streamline the development. Here's how the flow works. The controller receives the user's input and routes it appropriately. Next is the service that contains the core logic. This is where data are differentiated, calculated, and validated whether it is compatible to the user on, let's say, the kinds of exercise or meal plan that they have in store. Next is the model that interacts with the database, handling the data persistence of all types of exercise and meal plans. And lastly, the view presents the final output to the user, or it's just considered the UI. By also integrating services into our MVC design, we are able to create a flexible and more scalable architecture that clearly separates the responsibilities and support for future enhancements. For our code highlights, it mostly involves the exercise interface that plays a major part in our project. It is mainly because we needed to ensure that it can store vital data of each objects to have an easier time to create a filtering logic when choosing our exercise, such as knowing the type of goals that the user wants, what kind of injuries they have, or the equipment they have available to them. So this greatly affects many of our classes that previously used a more simplified list array that is basically hard coded into the project. And the only challenge that we face when implementing the interface is by ensuring that all the classes and methods have fully integrated the new updated solution to the project.
These are some of the challenges we've encountered. We've mostly encountered cannot find symbol errors. This happened because we tried to use a getGender method in one file, which is the BMI calculator controller, before it was properly defined in the user Java class. To make the gender feature work, we would have needed to update the user service to properly save and load the new data field. However, there are mismatches in the number of fields that caused parsing errors when the app tried to read the broken user data. Whenever we tried to add a new feature, such as encryption, we had to make new classes under utils, and we had to update every single file that related to it. When we tried fixing the meal plan controller class, we encountered problems when we changed the code since we wanted to add a new feature, and upon pressing the button, the UI completely changed. These are the possible future improvements for the app. First is nutrient tracker. Aside from calories, the app should monitor your protein, carbs, fats, and micronutrients. Next is sleep and hydration tracker. This provides a more complete health profile. Next, workout videos. Built-in exercise demonstrations to guide the user. Next is push notifications and reminders. Encourages the user to exercise, drink water, and log their meals. Next is challenge mode. Weekly diet and fitness challenges to boost motivation. Next is community feature. Connect with other users, share progress, and exchange workout or tips. Next is wearable health tracker integration. Sync with devices like Fitbit and Apple Watch for real-time activity and calorie data. Next is recipe customization. Allows the user to customize ingredients based on their preferences. And lastly, food suggestions. Recommend meals using in-season or locally available ingredients. To conclude our presentation, our health app goes beyond simply calculating BMI. It serves as a comprehensive health and fitness partner that adapts to the user's unique journey. From the moment a user creates an account, they can log key details such as their weight, height, target weight, daily calorie goal, target BMI, and activity level. Using this information, the app generates personalized meal plans and workout routines that can be customized to match their preferences and goals. Looking ahead, we envision adding innovative features such as AI-driven recommendations, wearable device integration, and interactive community support to make the health app management more engaging and accessible. Our mission is to make fitness, nutrition, and healthy living achievable for everyone, turning goals into reality, one personalized plan at a time.